Hello, my name is Gabe Clemente. I'm an undergraduate researcher at the University of San Diego in Dr. Lauren Benz's lab, and this is a day in my life. I usually wake up around 7 to either go to the gym or read some literature for the upcoming day. I try to leave for campus around 9 after a shower and packing my lunch. Whoops, almost forgot the keys. My walk in the morning is always so beautiful, and every morning I pass the construction of the new Shiley Science Building. I hope it gets done soon so I can experience some classes in there. My day starts in the lab around 9:30. There's our periodic table paint on the wall. Here's our drying glassware, and next to it are our chemicals and fume hood. And here's our crown jewel, our X-ray photoelectron spectroscopy machine. There are 3 of us in the lab. Jordan is coming back from a trip today, but Miley's here now. Her view from our lab is pretty awesome as well. After I get in, I set up for the day. And after that, I like to talk with my research advisor. This is the chemistry department office suite. Good morning, Dr. Benz. We always have to practice good lab safety, so I wear my coat, protective eyewear, and gloves. I'm handling the XPS sample holder with a bead from historic jewelry from the island of San Salvador and its indigenous people, the Lucayans. I already ran analysis on this sample, so now I'm switching gears. I have to lower the stage of the sample holder and put on a new plate to begin running analysis on pure calcite and aragonite samples. Calcite and aragonite are 2 different types of calcium carbonate, which many historians speculate the bead is made of. We got these samples from Dr. Eric Cathcart, a geologist who also teaches and does research here at USD. When the pressure is optimal, I put the samples in the chamber. But before I run analysis, I have to wait for the pressure to optimize again. In the meantime, I make my experiment tree, where I pick the spots on the sample like so, and I select the elements I am scanning for. Each element should have a specific binding energy. The binding energy is the minimum energy required to disassemble a system into its constituent parts. After picking my points and selecting my elements, this is what my element tree in the optical view looks like. This is the sample moving into the analysis chamber that holds the ray gun. The ray gun blasts the surface with X-rays, causing electrons to be ejected. We measure the exact energies of these electrons to get the binding energy. Once it gets into the chamber, the machine needs to find the exact height and focus correctly on the sample. This is the survey scan, which shows all the binding energies of all the elements in the sample. It becomes more and more accurate after each scan. These are more samples from Dr. Cathcart and his studies of the Lucayan artifacts. They are in a vacuum oven to get any organics out of the sample in preparation for the XPS machine. I usually take my lunch around 12. Usually I pack a lunch, but today I got a sandwich from Alivas in the business building. I love the view behind the Shiley Center. Since today is Tuesday, we have a group meeting in conjunction with Dr. Gillette's and Dr. DeHaan's lab. I need to summon the people first. At this meeting, we present our findings for the week like I am doing here. After group meeting, I do some more data analysis when my samples run. These are samples that a professor from Cal Poly Pomona asked us to run. I do a lot of data fitting, where I have to fit the peaks and get the smallest chi-squared value with a reasonable amount of doublets or singlets. I did this until lab hours were over at 4:30. Thanks for watching my day in the life.